Welcome to the lecture class 2 for CBSE class 12 chemistry students. Last class we saw the various ways of representing the concentration of solution, namely mass percentage, volume percentage. Then we have seen part per million, mole fraction, molarity and molality we have seen. And we have also written the formula for each concentration. How to find out the concentration? We wrote the formula for finding out the concentration. This class, we will see the effect of temperature on the solubility of a solid in a liquid to give a solution. Then we will work out numerical based on concentration of solution. While doing numerical, always make sure that you have written the formula clearly and shown the substitutions very clearly here, right? Because this carries mass. If there are 2 marks awarded for a numerical. At least one to 1.5 marks we'll get by writing the formula and showing the substitution clearly. And of course, units also is taken into account. Units for the answer is also taken into account here. So you should always make sure to write the formula, show the substitution very clearly, and then carry out the working here, right? Now let us see the effect of temperature on the solubility of a solid in a liquid to give a solution. Then let us work out some numerical based on concentration of solution. Right. We'll see the effect of temperature and concentration of solution. In a closed system, I'm taking a closed system. I'm increasing the temperature. Mass of the solute and solvent will not get affected here. Whereas the volume of the solution will expand on heating a solution. I'm looking at a closed system. When I increase the temperature, mass will not change, but the volume of the solution will expand here. Molality is number of moles of solute divided by mass of solvent in kilogram. Number of moles of solute is nothing but mass by molecular mass. So only mass are involved in molality. Therefore, increase in temperature will not affect the molality here. Because molality based on mass only. Number of moles of solute divided by mass of solvent in kilogram. Whereas molarity is number of moles of solute divided by volume of solution in decimeter cube or liter here. So here what happens, molarity, when you increase the temperature, volume is going to expand here. The expansion of volume will take place. Therefore, the molarity will decrease on increasing the temperature here. Molarity will decrease on increasing the temperature because the volume is expanding. Molarity is nothing but number of moles divided by volume of the solution in decimeter cube here. So this is the effect of temperature on molarity and molality. Molality does not change with increase in temperature. Molarity will decrease as the temperature increases here, right? Now let us see. There are two types of process we have seen here. One is called as exothermic process, other one is known as endothermic process. When I take a solid, dissolve it in a liquid to give a solution, the reaction may be exothermic or endothermic. Exothermic means heat energy is given out by the system to the surrounding. Endothermic means heat energy is taken in by the system from the surrounding. Right? If it is an exothermic reaction, lower temperature will favor the exothermic reaction. The exothermic reactions are favored at a lower temperature. The exothermic reactions are favored at a lower temperature. Therefore, as the temperature increases, solubility will decrease. Solubility will decrease, right? Whereas endothermic reactions are favored at a higher temperature. Delta H is greater than 0 for an endothermic reaction. Most of the reaction where solid dissolves in a liquid to give a solution are endothermic reactions there. Most of the reactions are endothermic. Therefore, solubility will increase as the temperature increases here. Solubility will increase when the temperature is increasing. See, for example, I'm taking sodium chloride, dissolving it in water at 50 degrees Celsius. So let us say 2 grams of sodium chloride is soluble in a given amount of solvent. I'm increasing the temperature to 60 degrees. Some more solute can be dissolved. From 2 grams, it may go to 2.5 grams will be dissolved in the given amount of solvent. at 60 degree here. So the solubility will increase as the temperature increases here. That's very important. And exothermic reactions favorable at a lower temperature. Solubility will decrease as the temperature increases. Endothermic reactions are favorable at a higher temperature. Therefore, solubility will increase as the temperature increases. Most of the cases where solid dissolves in a liquid solution are endothermic reactions here. Right. Now let us see the numericals based on concentration. Before that, take down the formula so that you can work out the numerical here. First one is percentage mass of a solute. That is amount of solute present in 100 gram solution. That is called as percentage mass of a solute. Is nothing but amount of solute present in 100 gram solution. So I can write it as mass of solute divided by mass of solution into 100. That gives you the percentage mass here. Mass of solute divided by mass of solution in 100 will give you percentage mass here. And let's say 5% by mass of sodium chloride. 5 gram of sodium chloride is present in 100 gram solution. That is the meaning here. 5 gram of sodium chloride present in 100 gram solution. In other words, I can say solution contains 100 gram solution contains 5 gram sodium chloride, 95 gram water. Total 100 gram solution. Then volume percentage. That is the amount of solute present in 100 centimeter cube solution or 100 ml solution. That is called as volume percentage. Volume of solute divided by volume of solution into 100. That is called as volume percentage. When I say 5% by volume of ethanol, that means a 100 ml solution of ethanol contains 5 ml of ethanol, 95 ml of water here. That is the meaning of volume percentage. Amount of solute present in 100 ml or 100 centimeter cube solution. Part per million. Normally it is used when the gas molecule is dissolved in a solvent because solubility of a gas is very less here. The solvent is very less. That's why we go for part per million here. It is the amount of solute present in 10 power 6 gram solution. Or we say million gram solution. What is the amount of solute present here? So part per million is nothing but mass of solute divided by mass of solution into 10 power 6 here. Mass of solute by mass of solution into 10 power 6. Note on this formula so that you can follow the numerical done later on very easily. Then what do you mean by mole fraction of solute? Mole fraction, say for example, a solution is made up of a solute and a solvent. Let us say sodium chloride is a solute. Water is the solvent. I'm getting a sodium chloride solution. I want to know what is the mole fraction of sodium chloride, that is solute. Then what is the mole fraction of water, that is solvent here. So mole fraction of solute is equal to number of moles of solute divided by total number of moles. That is number of moles of solute plus number of moles of solvent here. That is called as mole fraction here. Mole fraction of solute. Mole fraction of solvent is nothing but number of moles of solvent divided by number of moles of solute plus number of moles of solvent here. So if you add all the mole fraction, it is equal to 1 here. In a solution, you add all the mole fraction, it becomes equal to 1 here. That is mole fraction of solute plus mole fraction of solvent equal to 1. Molarity is very important. It is the number of moles of solute in 1 decimeter cube, or we say 1 liter solution. That is called as molarity. The number of moles of solute in 1 decimeter cube solution or 1 liter solution is known as molarity here. That is nothing but mass of solute divided by molecular mass of solute into 1000 by volume of solution in centimeter cube. If I take volume of solution in centimeter cube, then we write it as mass of solute divided by molecular mass of solute. That gives you the number of moles of solute into 1000 by volume of solution in centimeter cube. In case the percentage mass is given, if the percentage mass is given, then I write it as percentage mass of solute divided by molecular mass of solute. Percentage mass of solute divided by molecular mass of solute into 10 into density of solution in gram per centimeter cube. So molarity, two formulas we use here. One is mass of solute by molecular mass of solute into 1000 by volume of solution in centimeter cube. Second one is percentage mass of solute by molecular mass of solute into 10 into density of solution here. Note on this formula. Unit of molarity is mole per decimeter cube or mole per liter here. Unit of molarity, mole per liter or mole per decimeter cube. 1 liter equal to 1 decimeter cube, which is equal to 1000 centimeter cube here. That's for conversions, you can use it. Then molality. Molality is number of moles of solute in 1 kilogram of solvent here. Only mass is involved here. Molality is number of moles of solute in 1 kilogram of solvent is called as molality. That is number of moles of solute divided by mass of solvent in kilogram. Or I can write it as mass of solute by molecular mass of solute into 1000 divided by mass of solvent. That is the molality here. Mass of solute by molecular mass of solute is the number of moles of solute into 1000 by mass of solvent here. That is molality. 1 kilogram equal to 1000 grams here. For conversion, 1 kilogram is 1000 grams. So this is molality. Mass of solute divided by molecular mass of solute into 1000 by mass of solvent. If percentage mass is given, then percentage mass of solute by molecular mass of solute into 1000 by 100 minus percentage mass of solute here. Percentage mass is given means percentage molality equal to percentage mass of solute divided by molecular mass of solute into 1000 divided by 100 minus percentage mass of solute here. Right. These are the formulas we have taken. Now let us see the numerical based on concentration of solution. First one is a sample of drinking water contains 15 part per million chloroform CHCl3 by mass. Express this in percentage mass. Generally, when they give compounds containing carbon, hydrogen, chlorine, etc., they may not give you the molecular mass in the paper, board paper. They may not give you the molecular mass. So it's better to know the molecular mass of at least first to 20 elements. Of the calcium, it's better to know carbon, hydrogen, nitrogen, oxygen, NO2, if it is involved in a numerical. They will not give you the mass of molecular mass of NO2. You have to calculate the molecular mass of NO2 so that you keep it in mind. Here, of course, I give the molecular mass of CaCl3 equal to 119.5. A sample of drinking water contains 15 part per million chloroform. Express this in percentage mass. See, 15 part per million means 10 power 6 gram solution contains 15 grams of chloroform. That is the meaning here. If we take 10 power 6 gram solution, that contains 15 grams of chloroform. Now I want to find out how much of chloroform is present in 100 gram solution. That is percentage mass here. 100 grams, how much is present here, right? So I have written 10 power 6 gram solution contains 15 grams of CaCl. 100 gram solution contains how much? So 15 into 100 by 10 power 6, which is 15 into 10 power minus 4, which is the mass percentage of chloroform. Then I have to find out the molality here. Now I know the mass percentage of chloroform. I have to find out the molality. Earlier we used the formula using the mass percentage. Molality is equal to percentage mass of solute divided by molecular mass of solute into 1000 by 100 minus percentage mass. I can use this because I know the mass percentage here. Percentage of mass of solute divided by molecular mass of solute into 1000 by 100 minus percentage mass here. So percentage mass is 15 into 10 power minus 4 divided by 119.5 is the molecular mass into 1000 divided by 100 minus 15 into 10 power minus 4. That is percentage mass of chloroform is 15 into 10 power minus 4. So 100 minus 15 into 10 power minus 4, I can take it as 100 here because it's very 15 into 10 power minus 4 value is very small, negligible. So I can take it as 100 minus 15 into 10 power minus 4, I can take it as 100 here. So I written 15 into 10 power minus 4 into 1000 divided by 119.5 into 100. That comes to 1.256 into 10 power minus 4 mole per kilogram. Unit is very important. Sometimes unit carries half a mark here. Or 2 marks numerical, unit will carry half mark. If you don't give the unit, you will end up with 1.5 marks. So you should be very careful here. First you write the formula, then show the substitution, then write the answer with the unit here. Right. Next numerical will say concentrated sulfuric acid is 49% by mass. Density of the solution is 1.5 gram per centimeter cube. So percentage mass is given, density is given. Determine the molality, molarity, and mole fraction of sulfuric acid in the solution. Molecular mass, I have given it as 98. It may not be given as well because sulfur 32, oxygen 16, hydrogen 1, you should be knowing it. So molecular mass of sulfuric acid is 98. So here it is, percentage mass is given, density is given. Molecular mass I can find out. Using these three factors, I have to find out the molality, molarity, and mole fraction here. Right. We'll see how to do it. There are two methods you can take. The first one is using the formula directly. Molarity equal to percentage mass by molecular mass into density. That is the molarity here. So percentage mass is 49. molecular mass is 98. So 49 by 98 into 1.5 into 10, which is equal to 7.5 mole per liter or mole per decimeter. So simple use of formula. Percentage mass is known to me, molecular mass is known to me, density is known to me. So I'm substituting it as percentage mass 49, molecular mass 98 into 1.5 is the density into 10 here. That gives you 7.5 mole per liter. Molality is percentage mass of solute divided by molar mass of solute into 1000 divided by 100 minus percentage mass divided by 100 minus percentage mass of solute here. So here also everything is known to me. Percentage mass is known to me. Molecular mass is also known to me. So molality is equal to 49 percentage mass. Molecular mass is 98 into 1000 divided by 100 minus percentage mass. That is 100 minus 49. 9.8 mole per kilogram. This one method of doing using the formula. The second one is using the definition, using the concept or definition I can find out. So when I say 49% by mass of sulfuric acid, it means if I take 100 gram solution, 49 gram is sulfuric acid, which is a solute, 51 gram is water, which is a solvent here. So I know the mass of solute and solvent here, right? I want to find out the molarity now. Molarity is mass of solute divided by molecular mass of solute into 1000 divided by volume of solution in centimeter cube. Density is given to me. Density is nothing but mass by volume here, right? Mass by volume is density. Or volume of the solution is nothing but mass by density. Mass is 100 gram solution. Density is 1.5. So 100 by 1.5 will give me the volume of solution. So I know the mass of solute is 49. Volume of solution is 100 by 1.5. Molecular mass of sulfuric acid is 98. So mass of solute is known, molecular mass of solute is known, volume of solution is also known to me. So I substitute here 49 by 98. 49 by 98 into 1000 by 100 by 1.5. That is 49 by 98 into 1.5 into 1000 by 100. Yeah, that's what we have. 1 minute, I'll push it up. Okay. So I have shown this substitution. Just we are substituting 49 by 98 into 1000 into 1.5 100. That is 7.5 mole per liter. Then molality, mass of solute by molecular mass of solute into 1000 by mass of solvent. Mass of solute is 49, molecular mass is 98, mass of solvent is 51. So I showed the substitution here. 49 by 98 into 1000 by 51. 9.8 mole per kilogram. Either you can go by the concept or you can use the formula. Of course, the formula is derived only from the concept. So any one of the method you can go for here. Then mole fraction is sulfuric acid is number of moles of sulfuric acid divided by total number of moles. That is number of moles of sulfuric acid plus number of moles of water. Number of moles nothing but mass by molecular mass. Sulfuric acid mass is 49, molecular mass is 98, so 0.50. Water is 51 gram because 100 gram solution contains 49 gram sulfuric acid, 51 gram water. 51 by 18, 2.83. So mole fraction of sulfuric acid is 0.50 divided by 0.50 plus 2.83, which is 0.150. Mole fraction of water is going to be, total mole fraction is 1, sulfuric acid is 0.150. So 1 minus 0.150 equal to 0.850 here, right? Next one is concentrated nitric acid is 68% by mass. Density of solution is 1.5 gram per centimeter cube. Calculate the volume of solution containing 20 grams of nitric acid. So percentage mass is given to me, density is given to me. I want to find out how much volume of the solution will have 20 grams of nitric acid. Molecular mass of nitric acid, I calculated, it is 63 gram per mole here, right? First method is I'm using the formula. That is molarity I can find out because percentage mass is known to me, density is known to me. So percentage mass by molecular mass into 10 into density will give you the molarity here. So I'm finding out what is the molarity of the solution here, right? That is 68 by 63 into 10 into 1.5. That is the molarity. Another formula I know for molarity is mass of solute by molecular mass of solute into 1000 by volume of solution, right? Molarity I am finding out 68 by 63 into 10 into 1.5. That is percentage mass of solute divided by molecular mass of solute into 10 into density. I am using the second formula for molarity. Mass of solute 20 grams I have taken. 20 grams divided by molecular mass 63 into 1000 by volume of solution. Molarity is same solution only. I want to find out what is the volume occupied by 20 gram of nitric acid. So I can write 68 by 63 into 10 into 1.5 is equal to 20 by 63 into 1000 by volume of solution. So find out the volume of solution, 19.61 centimeter. So first we find out the molarity, write the formula 68 by 63 into 10 into 1.5. Another formula, molarity is equal to mass of solute by molecular mass of solute into 1000 by volume of solution centimeter cube. 20 by 63 into 1000 by volume of solution. Then both are equal. So I can write it as 68 by 63 into 10 into 1.5 is equal to 20 by 63 into 1000 by V here. Find out the volume of solution, 19.61 centimeter cube. This is one method here. Another method is density is 1.5 gram per centimeter cube. That means if I take 1.5 gram solution, that will occupy a volume of 1 centimeter cube. If I take 100 gram solution, that will occupy a volume of 100 by 1.5 centimeter cube. Right. So I know what is the volume occupied by 100 gram solution. Then the percentage mass is given as 68 grams. So 100 gram solution will have 68 gram of nitric acid. 100 gram solution will have 68 gram of nitric acid. So I can write it as 68 gram of nitric acid will occupy a volume of 100 by 1.5 centimeter cube. 68 gram of nitric acid, if I take, it will have a volume of 100 by 1.5 centimeter cube. 20 gram of nitric acid, what is the volume occupied? So 100 by 1.5 into 20 by 68, which is 19.61 centimeter. So any one of the method you can use here. Any one of the method you can use here. But then you have to show it step by step here. You have to show it step by step to get the answer, because every step will have some mark in the marking scheme. So very careful about it. Just don't write the answer and leave it. Show how you have done it. Now we'll take one textbook, numerical. Sodium carbonate and sodium bicarbonate, Na2CO3 and NaSCO3 mixture containing 1 gram is completely neutralized by 0.1 molar HCl. Determine the volume of HCl required if the mixture contains equimolar mixture. Equimolar mixture means number of moles of sodium carbonate is equal to number of moles of sodium bicarbonate in the mixture. That is called as equimolar mixture. Number of moles of sodium carbonate and number of moles of sodium bicarbonate is same. Molar mass of sodium carbonate 106 gram per mole, sodium bicarbonate 84 gram per mole. So I have taken a mixture of 1 gram containing sodium carbonate and sodium bicarbonate. Both will react with HCl to give salt, water, and carbon dioxide. Salt, water, and carbon dioxide. How much of HCl is required? I have taken 0.1 molar HCl, that is 0.1 mole per decimeter cube, or 0.1 mole per liter of HCl is taken. How much volume is required to completely neutralize sodium carbonate and sodium bicarbonate? One more information given here is number of moles of sodium carbonate is equal to number of moles of sodium bicarbonate. Right. Now let us see 1 gram. Let us see sodium carbonate mass is x gram. Sodium bicarbonate is 1 minus x gram. The number of moles is mass by molecular mass. Number of moles of sodium carbonate is x by 106. Sodium bicarbonate is 1 minus x by 84. Moles are same here, equimolar. So I can write it as x by 106 equal to 1 minus x by 84. By solving the equation, I get x equal to 106 by 190. That is the mass of sodium carbonate is 106 by 190. Now I can find out the number of moles of sodium carbonate. That is mass divided by molecular mass. That gives the number of moles of sodium carbonate. That's what we have done. 106 by 190 again divided by 106 here, which is, I've shown the substitution here, 1 by 190 moles here. So number of moles of sodium carbonate is 1 by 190 moles. Sodium bicarbonate is also going to be same here because equimolar solution. Number of moles of sodium bicarbonate also 1 by 190 moles. That is the first part here. Finding out what is the number of moles of sodium carbonate, what is the number of sodium bicarbonate. Both number of moles are same and it is equal to 1 by 190 moles. Then write the equation. Na2CO3 plus 2 HCl gives 2 NaCl plus H2O plus CO2. That means 1 mole of sodium carbonate will require 2 moles of HCl. Stoichiometry, you look at it. 1 mole of sodium carbonate needs 2 moles of HCl. So 1 by 190 moles of sodium carbonate needs 2 times the moles of sodium carbonate taken. That is 2 by 190 moles of HCl. Right. For sodium carbonate, I need 2 by 190 moles of HCl. Sodium bicarbonate, I am looking at NaSCO3 plus HCl gives NaCl plus H2O plus CO2. This is the equation. Here it is 1:1 ratio. 1 mole of sodium bicarbonate requires 1 mole of HCl. 1 by 190 moles of sodium bicarbonate require 1 by 190 moles of HCl. So total number of moles is 1 by 190 plus 2 by 190. So total 3 by 190 moles of HCl is required here. So I know the number of moles of HCl required for complete neutralization. Now the concentration is given here. Concentration is nothing but number of moles divided by volume of solution in decimeter cube. Concentration, that is molarity, is 0.10. Number of moles is 3 by 190. So 3 by 190. Volume of solution I can find out by showing the substitution here. So volume of HCl is 3 by 190 to 0.10, which is equal to 157.8 centimeter cubic. Of course, I get the answer in decimeter cube. I can convert it to centimeter cube. So first I am finding out what is the number of moles of Na2CO3. We'll just see it again how I have gone about. So mass of Na2CO3 is x gram. Sodium bicarbonate is 1 minus x gram. Number of moles mass by molecular mass, x by 106 for sodium carbonate, 1 minus x by 84 by sodium bicarbonate. Number of moles are same. So x by 106 equal to 1 minus x by 84. X is 106 by 190. That is the mass of sodium carbonate. Then mass by molecular mass will give the number of moles. So I'm finding out the number of moles of sodium carbonate. This is 1 by 190 mole. Number of moles of sodium bicarbonate is also same here. Then I'm writing the equation. 1 mole of sodium carbonate requires 2 mole of HCl. So 2 by 190 mole of HCl is required. And then NaHCO3, 1 mole of sodium bicarbonate requires 1 mole of HCl. So 1 by 190 moles of HCl is required. Total number of moles of HCl required is 1 by 190 plus 2 by 190, 3 by 190. Now molarity is number of moles divided by volume. Molarity is known to be, number of moles is known to be. So I'm going to find out the volume of solution, which is 157.8 centimeter cube. Right. Now we'll do a numerical based on finding out the molality from molarity. Molality from molarity. Calculate the molality of 1 molar solution of sodium nitrate. Density is 1.25 gram per centimeter cube. Molar mass of NaNO3 is 85. This is simple method is using the formula. Molarity is given 1 molar solution. That means 85 gram of sodium nitrate dissolved in 1 decimeter cube of solution. Present in 1 decimeter cube of solution. Right? So molarity is percentage mass by molecular mass into tangent density. Percentage mass, you see here the molar is given. So molarity is known to be 1. I can find out the percentage mass of solute. By using this formula, I'm finding out the percentage mass of solute. Molarity is 1 here. Molecular mass is 85. Density is 1.25 gram per centimeter. So I substitute the value. Percentage mass by 85 into 10 into 1.25. So percentage mass of NaNO3, I calculated it as 6.8%. So I know the percentage mass here. So I want to find out the molality here. Molality is as for percentage mass by molecular mass into 1000 by 100 minus percentage mass. Now percentage mass is known to be 6.8. Molecular mass is given 85. So 6.8 by 85 into 1000 by 100 minus 6.8. That comes to 0.858 mole per kilogram. Just by using the formula, substituting it. First I found out the percentage mass using the molarity. Then using the percentage mass, I'm finding out the molality here. Another method is using the concept here. See, I've taken 1 mole of sodium nitrate solution. That means 1 mole of sodium nitrate in 1000 centimeter cube solution. 1 mole means 85 grams. So 85 grams of sodium nitrate present in 1 liter solution or 1000 centimeter cube solution. Density of solution is given. So I can find out the mass of 1000 centimeter cube solution. 1.25 gram per centimeter cube is the density. So 1.25 into 1000. 1250 grams is the mass of solution here. Out of which 85 grams is solute. So solvent is 1250 minus 85, 1165. So mass of solvent is known to be. So I can use the formula directly now. Molality equal to mass of solute by molecular mass of solute into 1000 by mass of solvent. Mass of solute is 85. Molecular mass of solute is 85. That is 1 molar. So 1 you can write into 1000 by 1165 here. 1000 by 1165. That is 0.858 mole per kilogram. So this is calculating molality for the molarity. Right. Now, other way around I'm looking at here. Finding out the molarity from molality. Molarity from molality here. Calculate the number of moles of methanol in 5 liters of 2 molar solution. Molality is given. Number of moles in 1 liter is molarity. 5 liter means I will multiply by 5 later on here. Density is given as 0.981 gram per centimeter. So now molality is known to me, density is known to me. So I can use the formula to find out the percentage mass here. Molality equal to 2, which is equal to percentage mass of solute, divided by molar mass of solute into 1000 by 100 minus percentage mass. Okay. So percentage mass of solute I want to find out. Molar mass is known to me. Methanol it is 32. So I can find out the molality is also known to me. I can find out the percentage mass here. So 2 is equal to its molality equal to percentage mass by 32 into 1000 by 100 minus percentage mass. So I am finding out the percentage mass by cross multiplying. 64 into 100 minus percentage mass equal to 1000 percentage mass. So percentage mass of the solute is 6.015 is the percentage mass of the solute. Now I'm going for the molarity. Percentage mass by molecular mass and determinant density. Percentage mass is known to me. So 6.015. Molecular mass is 32. Density is given as 0.981 gram per centimeter cube. So substituting 6.015 by 32, it determined to 0.981. That comes to 1.843 mole per liter or mole per decimeter cube. So 1 liter solution contains 1.843 moles. 5 liter solution contains multiplied by 5, 9.215 moles. This is one method here. Another method is using the concept. 2 molar solution of methanol means 2 moles of methanol present in 1 kilogram of solvent. Molarity is number of moles of solute in 1 kilogram of solvent. So 2 moles of methanol in 1 kilogram of solvent. 2 moles of methanol is 2 into 32, 64 grams. Solvent is 1000 grams. So mass of 2 molar solution is 1064 grams here. Mass of 2 molar solution is 1064 grams here, right? Then you find out what is the mass of 5 liter solution of methanol. Density is 0.981 gram per centimeter cube. 5 liter means 5000 centimeter cube. So 0.981 into 5000 is 4905. 4905 grams. 4905 grams is the mass of 5 liter solution of methanol. Earlier we have seen 1064 grams of solution contain 2 moles of methanol. 4905 grams of solution contain how much of methanol you can find out. 4905 into 2 by 1064, which is 9.21 moles here. So either way you can go for the numerical, either by using the concept or by using the formula. Right. Next one is if the solubility product of copper sulfide, CuS is 6 into 10 power minus 6. Calculate the maximum molarity of CuS in aqueous solution. See, solubility product is nothing but product of concentration of products each raised to the stoichiometric coefficient. Product of concentration of the products each raised to the stoichiometric coefficient. So CuS, if I dissolve it in water, it will give me Cu2 plus aqueous and S2 minus aqueous. So both are 1:1 ratio here. Only 1 mole of Cu2 plus 1 mole of S2 minus is present here. So Ksp is equal to Cu2 plus into S2 minus here. The value is given as 6 into 10 power minus 6 here. Both are same concentration here. So X and X. I am taking concentration of Cu2 plus equal to concentration of X2 minus, which is X here. So X into X is equal to 6 into 10 power minus 6 here. So X square is 6 into 10 power minus 6. Molarity X, that is concentration. Root 6 into 10 power minus 6. That is 2.445 into 10 power minus 3 mole per liter. This is the concentration of solution. So this is using the solubility product that you studied last year. Just write the formula, find out the X value, that is the molarity of the solution. Maximum molarity of the solution. Last one is, again, the textbook numerical. Calculate the mass of urea required in making 2.5 kilogram of 0.25 molar solution of urea. Molecular mass of urea is 60 gram per mole here. It's given 0.25 molar solution of urea. 2.5 kilogram I have to prepare here, right? Mass of urea required in making 2.5 kilogram of 0.25 molar solution of urea. When I say 0.25 molar solution of urea means 0.25 moles of urea is present in 1 kilogram of solvent here. 0.25 grams of urea is present in 1 kilogram of solvent. That's the meaning here. Molar mass is 60 here. I can find out what is the mass of urea. 60 into 0.25. That is 15 grams here. Then what is the mass of 0.25 molar solution of urea here? Mass of solvent is 1 kilogram, 1000. Mass of solute is 15. 1015 gram is the mass of solution here. To prepare 1015 gram solution, I need 15 gram of urea. But here I want to prepare 2.5 kilograms. That is 2500 grams of solution I have to prepare. So 15 into 2500 by 1050. 26.95 gram of urea is required. So look at the definition. Molality means number of moles of solute in 1 kilogram of solvent. So I have taken 0.25 moles of urea. Find out what is the mass of 0.25 moles of urea. Molecular mass into number of moles. That will be the mass of 0.25 gram of 0.25 moles of urea. That is 15 grams. Find out mass of the solution. 1000 grams is the mass of the solvent, 1 kilogram of solvent. 15 grams is the mass of solute. 1015 grams. To prepare 1015 grams of solution of urea, I need 15 grams of urea here. To prepare 2500 grams solution of urea, how much I need here? So 15 into 2500 by 1015, which is 36.95. Okay. The next class, lecture 3, we'll see Henry's law, application of Henry's law, and numerical based on Henry's law here. We'll revise and we'll see the Henry's law, application of Henry's law, numerical based on Henry's law. Thank you. Make the best use of the video for your CBSE board exam. I'm Mr. Vasu. Thank you very much.